हाय फ्रेंड्स, हमने पहले कुछ लेक्चर में देखा था लैप्लास ट्रांसफॉर्म के फार्मूले, देन थ्योरम भी देखा था। अब हम एग्जांपल देखने वाले, दैट इज फाइंड लैप्लास ट्रांसफॉर्म t raised to 5 into e raised to 3t. We know the Laplace transform t raised to 5, this is Laplace gamma of n plus 1 divided by s raised to n plus 1, but here n is 5, so gamma of 5 plus 1 divided by s raised to 5 plus 1. This is simplified. Then this is gamma of 6 divided by s raised to 6. First lecture I say you, that is how to calculate the values of gamma of 6. This is 5 factorial divided by s raised to 6. Then this simplify, we s raised to 6, this is the values of Laplace transform of t raised to 5. Then we find values of Laplace transform of t raised to 5 into e raised to 3t. Then here is f of t. We know the theorem, Laplace transform of e raised to at into f of t. Here is f of t is t raised to 5, so Laplace transform of e raised to at f of t is equal to f of s minus a. Here s minus a is, this is s minus a, so here s minus a is s minus a, means here is a, s minus a, so s minus 3, here is s. So here this is 5 factorial, means 5 into 4 into 3 into 2 into 1, and s is s minus 3 raised to 6, brackets raised to 6. So this is we simplify, then this equal to, this is multiplication, is equal to 120 divided by s minus 3 raised to 6. Then another type of example is Laplace transform of e raised to minus t, 3 hyperbolic sin 2t minus 5 cos hyperbolic 2t. Then we know the Laplace transform of sin hyperbolic 2t, that is 2 divided by sin square minus 4 means 2 square 4. Then Laplace transform cos 2t is s divided by s square minus 2 square is 4. So this is 3 into, here is 3 into sin hyperbolic 2t, here is sin hyperbolic 2t, we put these values here, but here is minus 1, this is a, so this is a minus a, but here is plus 1 plus 1 plus 1 minus 1 minus 1 plus bracket raised to bracket square minus 4 means 2 square 4 minus 5 into cos of 2 hyperbolic 2t, that is s divided by s square minus 4, but here is s is here minus 1, so s plus 1 bracket square. We simplify this, so 6 3 into 2 6, and 5 multiply then 5, this is same base, so subtractions minus s, here is minus 5 plus 6, that is plus 1. Our equations is 5s plus 1 divided by s plus 1 bracket square minus 4. This is values of Laplace transform of e raised to minus t into 3 sin hyperbolic 2t minus 5 cos hyperbolic 2t. Then we write second theorem, fourth, that is second shifting theorem. This is if Laplace transform f of t is equal to f of s and g of t is equal to f of t minus a, when t is greater than a, if g of t is equal to 0, then t is less than a. Then this we have to prove. This is Laplace transform of g of t is equal to e raised to minus as f of s, or Laplace transform of f of t minus a into h of t minus a is equal to e raised to minus s f of s. Given, firstly we write given, that is given Laplace transform of f of t is equal to f of s. Here is given, and second is this g of t is equal to f of t minus a, t is greater than a, and 0, t is less than a. We know the Laplace transform of g of t, that is integration 0 to infinity e raised to minus st g of t dt. We change their limit from 0 to a e raised to minus st g of t dt plus integration a to infinity e raised to minus st g of t dt, but this is equal to 0 plus integration a to infinity e raised to minus st g of t dt. We have to prove this is also equal to 0 because class A, we remember first theorem, that is Laplace transform when exit. This function is class A. Class A means there is finite values, finite equations values, and exponential function. This is already exponential function, but this value is finite. Then this limit is exit. And then we prove this theorem. Then firstly we prove this is also equal to 0. Then put this is t minus a. Here is a, no, the t minus a. T minus a is equal to p. Then dt equal to dp. So here limit is when t is equal to 0, p is equal to, when t is equal to a, p is equal to 0, and t is equal to infinity, p is equal to also infinity. So we all these value put in here. So Laplace transform of g of t is equal to integration 0 to infinity e raised to minus st. Here is t means p plus a. Here is t. So here is we put p plus a. Here is p is equal to t minus a. So t is equal to p plus a. Then g of t minus a means p. G of p, and dt is dp. So then we separate this integration 0 to infinity e raised to minus sp into e raised to minus sa into g of p dp. But here is here is constant, e raised to minus a is constant, so out of the integration, then integration 0 to infinity e raised to minus sp g of p dp. But this is also, we know the Laplace theorem, that is integration 0 to infinity e raised to minus st. Here is variable p, there is t, minus st g f of t dt. So this is equal to f of s. So here is equal to e raised to minus sa. But we also know s is equal to p. So e raised to minus a f of s. So our theorem is proof. Laplace transform of f of t is equal to e raised to minus s into f of s. Then we have to solve one example on this theorem. So our example is example number first. This is find the Laplace transform of, we solve on the theorem. The example is this. We solve this example. The example is find the Laplace transform of f of t, where f of t is equal to cos of t minus 2 pi by 3, where t is greater than 2 pi by 3. If f of t is equal to 0, then t is less than 2 pi by 3. But we know the theorem. Here given. First we write given. Here is a means 2 pi by 3. We know t is greater than a, so this is a, and f of t, then t is f of t is cos of t. Here is t. So then we know the theorem. First we find Laplace transform of f of t. F of t is equal to, f of t is cos of t. So Laplace transform cos of t is p divided by p square plus a square. Here a is 1 square 1. So then we know the theorem. Laplace transform of g of t. Laplace transform g of t is equal to e raised to minus s. A is, what is a? This is a 2 pi by 3 p into f of t. F of t is Laplace transform of t is p divided by p square plus a. So this is the values of f of t is equal to cos of t minus 2 pi by 3 when t is greater than 2 pi by 3, where then f of t is equal to 0 when t is less than 2 pi by 3. This is Laplace transform is equal to e raised to 2 pi by 3 into p divided by p square plus 1. So then another example we can write in next lecture. So thank you.